So that acronym, PEAR, stands for Princeton Engineering Anomalies Research. It didn't have a name when I first joined, but a series of coincidences showed that it must be called the PEAR Lab. The PEAR Lab was one of the more, well, probably the most prominent lab for a long time. The dean of the School of Engineering, whose name was Bob John, was asked by a student to sponsor or monitor a research project where she was testing the idea that human intentions might change the behavior of a random number generator, which I probably will have to explain. And she couldn't get any faculty members to sponsor it. And so she asked the dean, how about the promise you made to let us do, if we do good work, to let us do the independent study we wish? And so he said, okay. And what happened then was that she found not only a lot of research that others had done, but she herself built a system to test the idea that human consciousness could interact with a random, with an electronic random device. And the evidence convinced him that there really should be a program of studying this kind of interaction of human consciousness with the physical world. So he built a lab in the basement of the engineering school and hired Brenda Dunn to help manage that laboratory. And not long after that, hired me from northern Vermont to come down and be a third member of the team. We grew to about 7 or 8 people along the way, did high-quality research, the best research protocols we could imagine, based on other people's work and our own understanding, and showed that indeed, if people are asked to change the behavior, change the output of a random number generating system, they could do it. Not always, and not necessarily a great deal, but enough to demonstrate scientifically that it's possible for human consciousness to interact with a random number generator. The second line of research was the random, usually random based, but some kind of interaction with mechanical or optical or some kind of engineering systems. We tried, we built a huge database using the electronic random number generators, but we had also what we call the random mechanical cascade, which is a huge machine with 9,000 balls bouncing around in an array of pegs and being counted. They fell ultimately into a Gaussian distribution. We asked people to shift it this way or that way, and again they could. They did in the experiments. There were several others, a fountain, water breaking up from a laminar flow to a turbulent flow. We asked people to change the place where that happened. An ultimate conclusion I came to, and I think all of us more or less agreed, was that it doesn't really matter very much whether it's mechanical or optical or electronic. If it's a random system, if it has a random process at its base, then people can change the way the data accumulate just by thinking about it. When I first came to the lab, there was a kind of prototype random number generator, and I've helped shepherd the development and construction of a random number generator. There was a box this wide, this tall, and this deep. In other words, like a suitcase. That was the first. That was in 1980. This is today's style of random number generator. So we would ask, basically, we would ask them to be comfortable. The machine is on the table 1 meter or 1.5 meters away. It has the displays which will show the outcome of each trial. And so we ask them to just try to get high numbers now.
High numbers, what do you mean? Like
numbers that are more than 100 in this case. So if there are 200 bits.
Okay, to think of numbers, of those higher number?
Well, we didn't tell people what to do. We just told them the goal, and the goal was in a situation where the numbers will be made of 200 coin tosses. It will be a number close to 100, but it could be more, it could be less. So in the high intention, we said, try to get high numbers. And a high number is anything over 100. 110 or 120, those are both very good achievements if you're trying to get high numbers. 95, 90, very good achievements if you're trying to get low numbers. So people got feedback from the device, or maybe from a graph that was showing the steps in the random walk that's proceeding. But thinking in the earliest, simplest terms, they just saw a number that came up on the LED display that was 102, then they were happy because they were trying to get a high number. People quickly learned that if you're throwing the coin 200 times, you will get about 100 heads. But if you're lucky, or if you're successful in connecting with the machine, you'll get 105 or 107. Remember, I said that sometimes people succeed and sometimes they don't. That's always true in these kinds of experiments. Nobody is a master able to make every coin flip a head. We know that from not only our experiments, but experiments all over the world, and sometimes especially looking for special people who claim to be able to do things that are impossible. So nobody is able to be right all the time, you might say.
Yeah.
Oh, we were in business for a long time. We weren't the first. There was probably the first serious computer-controlled electronic random number generators, or random generators based on something like radioactivity, was a man named Helmut Schmidt. He worked for a big aircraft company, Boeing. He was a researcher for them. And at one point he became interested in the possibility that some of the instrumentation, which had random components, it might be vulnerable to what people were thinking about or feeling. Strong emotions are an important factor. And anyway, he did research and kind of set a standard of high quality scientific work, which then a number of people, there was a laboratory in Durham that was created by J.B. Rhine. It's called and then there was a Parapsychology Foundation. Stanford University had something going on for a while. Yale University had at least one professor interested in these things. And then in Europe, there were in Germany and England especially, and Italy, there were installations. The Russians were very interested in these kinds of things, so they had, I don't know how many, 2, 3 serious labs funded nicely by the government. So there were, in Japan, but maybe a little later in China also, studying things like Qigong and other martial arts. Anyway, there were labs all over the world, and still so few compared to what happens in a physics question. There will be billions of dollars and hundreds of laboratories and thousands of researchers and so on. But this has always been a field that was difficult enough so that, and worse yet, ill-funded. So not very many academic researchers, well-trained, were able to actually do this kind of work. He is an interesting person because he invented a kind of experiment that used the same random number generator technology, but it was used to control the movements of a small robot, which had wheels, and he put it in a space which I think might have, I don't know if it was marked with a grid, but in any case he let it run in this area, and what would happen, because it was randomly controlled, was it would sort of go everywhere. It would move this direction and there, and gradually it would create a pattern covering the entire surface. And then he put live creatures, chicks, to begin with. It didn't seem to make very much difference. And then he did something very interesting. He put a candle on the top of this little tiny robot, and it then continued to move around, but no longer moved to cover the whole space. Instead, it tended to move more toward where the chickens were on one side of the area. So, and he did this in a number of different ways. One of the things that he thought was important was for the chickens, or I think he tried rabbits too, but chickens did something that I think is called implanting. They basically came to believe that this little robot with the candle was their mother. So they became especially attached, and that was the reason he thought that the robot would tend to come to them, because they were trying to be one with each other. This was kind of inspirational, and I think maybe other people tried it, but we at PEAR decided that is such an interesting and such a nice experiment. So we could do things like go to a party, or go to a concert, or go to the opera, or go to a business meeting, or go to a train station or shopping center. You might be able to see there's a couple of different kinds of things there. A concert will have a powerful focus. If it's people performing who are much loved by the audience, it will create such a powerful focus that almost the audience will be one, just drawn into the music and so forth. In a train station or a shopping center, not so much. Everybody was scattered. So the one has a kind of conducive quality toward cooperation, collaboration, shared feelings and all that kind of stuff. The other is just chaos. And we made the prediction that if we took our now miniaturized random number generators into the field, into these different kinds of conditions, we would find changes in the data away from what's expected. It won't be just random if we bring it to a church where there's a ritual going on, or the opera where the great arias are being sung. And we were right. So, and you don't always succeed. But we were able to basically ask a real world question. What happens when a group comes together for a purpose, or for the same purpose, or because something really attracts them all? Okay, so we should go back a couple of years to a time when, after doing these field REG experiments, the question of what happens if you have two devices, what happens if the device is far away, those kinds of questions became more and more clear. So I started developing plans for a global network of these same kinds of devices, the random number generators, but placed around the world. So and I started that in 1997, building the network. By 1998, we started taking data. And 3 years later, we had the 2001. At that time, we had 37 of these devices in Europe and America and Australia. Fiji, we had one, Alaska. The criteria were really simple and kind of vague. The simplicity was, what do we want? Lots of people. What do we want? Coherence. There should be a large number of people sharing, and in a kind of synchronized way, emotions especially. You know, it's like New Year's Eve is one of the kinds of events that we decided before we even had the network running. We will look at New Year's Eve. Why? Because really huge numbers of people come together just for a moment in time. It's not emotionally powerful in its own right, but because people come together to celebrate with each other and to raise a glass or to hug somebody right at midnight. What we could see does happen, and it does happen, is that people become synchronized and they become coherent with each other. They become focused on the same thing, not necessarily an important thing, but it's very clear. So we predicted that there would be a change in the data at midnight, or around midnight, and made a prediction. So we looked at a period of time, 10 or 15 minutes on either side of midnight, in each time zone, and we added all the time zones up so we could have a generalized, this is what New Year's looks like. And so what it looks like is, in one of our measures, such a nice pattern. The data, this is a timeline. The data are wandering along in an usual random fashion. About 5 minutes before midnight, they started dropping down. This is a variance measure. They become less variable. And then at exactly midnight, it turns around and it comes back up again. So we have this beautiful V-shaped pattern. It's a little rough, and some years it doesn't look so V-shaped. But over time, we were able to show a convincing departure from expectation for random data at midnight. And only, as far as anybody can tell, only because zillion people come together and hug each other. What I thought we might be able to do was capture some little bit of evidence that Teilhard de Chardin, who was a Jesuit priest but also a scientist, a paleontologist, he talked about evolution beautifully. If you want to think about evolution in poetic terms, read The Phenomenon of Man by Teilhard de Chardin. He said, we've evolved from simpler things and to become this amazing self-observing creature, human beings. And we think we're the pinnacle of evolution, but we're not. He said, we have more to do. We have another stage of evolution, at least that we can see, and that is to become what he called a noosphere. That's a sphere of knowing, or sphere of intelligence, a sheath of intelligence for the Earth. So that was his notion, and I thought that's a pretty good idea, and in principle possible. If we human beings would become cooperative and kind and appreciative and generous and all of those positive things, it would be amazing what would happen. We would become a sheath of intelligence for the earth. We would no longer have dominion, but we would have stewardship over the earth. We would take care of the earth. We wouldn't be interested in just exploiting and burning down the trees so we could farm better. We would be interested in cooperating with the trees to make the atmosphere, less carbon laden. Over time, if you're patient and you do the same kind of experiment again and again, in this case, it gradually builds up to the point where after a long time, after 17 years and 500 of these special, focused experiments, we were able to, say with great certainty that this is not a random database at all. This is what the physicists think of as a 7 sigma difference. I mean, 7 standard deviations. The normal curve is like this. 7 standard deviations is out here. That means doesn't belong to this normal distribution. It's very different. It's so different that it's, unless you can find a mistake or declare that it's all fraudulent or something like that, you simply can't escape the conclusion that the data change during these moments of special focused attention and emotion, especially emotion. There's that's a complicated question altogether. But I think in general, the answer to the question of whether global consciousness might be like human consciousness, I think it is. I'll give one other strong reason why I think so. The way we usually present the data is using a kind of cumulative deviation trace. It counts all the, adds up all the deviations during the period of time you're interested in. Normally, that results in a flat kind of random trace, what we call a random walk. But during an event, during a period of time when the data are changed, apparently, in correlation with an event, there are many more of the positive steps are added together to make a deviant trace, a departure from expectation. And I think that's a very nice display. It shows the history of what's going on, but a completely different kind of display is modeled after what people who study the brain do when they're looking at what happens if you flash a light or make a loud sound. What happens in the brain? And what you see is if you do the flash of light repeatedly, each time you repeat it, it's just like messy, noisy. But if you do it 100 times and add all those up, what's called epoch averaging, what you find is that just at the beginning of the stimulus, there's a drop down and then a rise up and a drop down again to a lower level. So in other words, there's a distinctive pattern when a stimulus hits the brain. If you analyze it correctly, you see this very clear shape, like that. And guess what? If we do that same kind of averaging to a lot of events from the Global Consciousness Project, you see the same kind of pattern. This drop down, a big spike, and then back. It's the same pattern. If I put one of my GCP data patterns using the EEG style processing, put that in a set of pictures that come from brain processing, nobody would know that was a global consciousness instead of a human consciousness. I am helping a bunch of people develop what's called GCP 2.0. It's Global Consciousness Project 2.0, the second version. We're, in other words, a follow-on project, which will be different in some major ways. For example, there will be 1,000 stations around the world, and each of those stations will have 4 random number generators, not just one. And there will be clusters in big cities, so we can ask all kinds of questions. There will be a collection of data from social media and from things like the geophysical sciences about what's happening to cosmic rays and geomagnetic fluctuation and all kinds of environmental variables that may matter. It'll be possible to look for correlations between that and the old network that's still running, and also between a network of sensors on trees, which are looking at the potential, you might say, interactive consciousness of trees. The laboratory ones allow us to see that we can be connected to the world, to the environment, in the form of these random devices. The field ones allow us to see that if we come together as a kind of coherent group, we become a group consciousness. And then the experiments that sort of develop from that, which we call the Global Consciousness Project, I think show clearly that the same thing is true on the large scale, on the planetary scale, that when people are all affected in such a way that they come together and share powerful emotions, that changes the world around them, and we detect that in our random data sequences. If we understand that we are actually one, there's nothing we can that we cannot do. You know. Unfortunately, it's not so easy in today's world. There's a lot of forces that push us apart. But I think we're on the verge of understanding how important it is. I hope we are on the verge of understanding how essential it is for us to learn more about this coherence that we are capable of achieving. We might need a little help from the Egyptian pyramids or from the great teachers. Yeah, there are people who are not just your run-of-the-mill guru, but people who have a kind of inspirational, charismatic quality. If you're around someone like that for a little while, you can become different. And you can recognize and adopt these understandings that we are, ultimately, we are one. We are all connected, which is basically the finding and understanding from these kinds of experiments. Your mission, if you're willing to undertake it, is to bring that unconscious connection up into awareness. Up to become a real interconnection that we feel and share consciously with each other. So, in other words, we can become consciously connected instead of only unconsciously connected. And if we, to the extent that we can do that, and I think people are doing it. There are many, many, many groups around the world who recognize this, and so they do meditations and exercises and loving sharing and all kinds of things in an effort to become one with each other, not just in theory, but in practice. We are all connected, And if we achieve a kind of conscious version of that interconnection, we'll be able to, as we used to have a sign in the PEAR lab that said, if we all work together, we can totally subvert the system. And what that means on the large scale is that if we all work together, we can do anything we want. We can have a beautiful world. It's possible to solve all the problems that we have. It's possible to stop the wars. It's possible to use our energies in constructive ways, not destructive ways. We have amazing potential. And most of us, you know, when we become aware that we have a potential that we haven't developed, we try. We can help each other with that. The potential we have as groups is just astounding, awesome. And I think also, finally, we have to say it's necessary. This is a time, and we are just in time, and we are the Hopi elders once said, a lot of other stuff, we are the ones we have been waiting for.